Hey everyone, ever wonder how AI learns to make smart choices without messing up? Like how a self-driving car decides whether to take a shortcut or stick to the safe route. Today, we're breaking down a game-changing approach called ORAC, short for Optimistic Risk-Averse Actor-Critic. That's helping AI balance boldness and caution like a pro. Let's dive in. So here's the thing. Traditional AI systems are like overzealous students. They'll push hard to maximize rewards, like a robot racing to the end of a maze. But what if the maze has hidden traps? A regular AI might crash into them, right? In real-world scenarios like medical systems or autonomous vehicles, that's a big no-no. That's where constrained reinforcement learning steps in, giving AI rules to stay safe while learning. But here's the catch. Being too safe can backfire. Imagine a robot that's so afraid of traps, it never explores the maze. It'll take the long, boring path instead of finding the shortcut. That's called suboptimal policies, solutions that work but not well. And that's where ORAC comes in. ORAC is like a curious explorer with a safety net. It doesn't just follow rules, it actively seeks out uncertainty while keeping risks in check. How? By using something called confidence bounds. Think of it as the AI saying, I don't know what's around the corner, but I'm going to check safely. Here's the magic. ORAC balances two goals. First, it maximizes potential rewards, like testing a risky shortcut to see if it's faster. Second, it minimizes the risk of catastrophe, making sure it doesn't fall into a trap. It does this by calculating smart guesses about how good a move might be. If a path looks risky but has high reward potential, ORAC gives it a try, but only if it stays within safety limits. Let's picture a grid-world maze. There's a short, high-reward path, but it's guarded by a hidden trap. The longer path is safe but less rewarding. Traditional methods might stick to the safe route, missing out on bigger gains. ORAC, however, expects the trap might not be there, and explores the risky path more thoroughly. Over time, it learns to balance risk and reward smarter than its predecessors. In experiments, ORAC outperformed existing methods. For example, in a maze where traps appeared 15% of the time, ORAC succeeded 100% of the time, compared to just 60% for a risk-averse competitor. It also reached the goal faster, converging to the optimal path in 230,000 steps versus 308,000 for others. But ORAC isn't just about rewards, it's about managing costs. In a building energy management simulation, it reduced outage violations by 10% compared to other methods, all while maintaining higher overall rewards. It's like a driver who slows down in bad weather, not to save gas, but to avoid an accident. The takeaway: ORAC proves that bold, risk-aware exploration can lead to better long-term outcomes. It's like giving AI the confidence to try new things without losing sight of the rules. Whether it's robots navigating tricky environments or systems managing real-world resources, this approach could make AI safer, more efficient, and more adaptable. So what do you think? How should we balance risk and reward in AI systems? Let me know in the comments. This is a critical conversation for the future of machine learning. Thanks for watching. If you want to dive deeper into how ORAC works or see it in action, hit subscribe. And remember, the next time you see an AI making a decision, it's not just about winning, it's about playing it smart. Stay curious.